So, we are picking up on lesson 7.5 where we left off, which we got through all but F on the front side pretty much. So I do want to pick up on F and talk about F. A, it will help us review where we left off, and B, it's a little bit more challenging problem, so it's good to talk about. Now, review briefly. As we were solving these exponential equations, what did we do up in the top row? If you look back to your top row, what were we doing up there solving those exponential equations? What was our goal? Yeah, solve for x, but what did we have to make happen? Yeah, we had to get the same base, right? That's why we were using the paper. We were using it to get the same base there. Then we hit example 2. In example 2, we couldn't get the same base. So what became our new plan when we couldn't get the same base? Okay, we had to take the log of each side, which really just means writing the word log on each side and then going from there. Now, the key is when we were taking the log of each side, and I don't know how much I specifically talked about this, but in order to take the log of each side, you want it so that you have just one term on each side. So in all these other examples we've done, notice it is one item raised to a power equals another number. There was never more than one term on either side. And that's where we run into the catch on F. Because F is 2 minus 3 to the x plus 1 equals negative 2. So now, I have my 3 to the x plus 1, but I also have other stuff. And so my first job, before we can think about taking logs or anything, is I need to have that power by itself. So how can I work to get 3 to the x plus 1 by itself? What was it? I don't want to use power property right now because I haven't taken logs yet. Okay, so let's move this 2, yes? If I want to take this 2 and move it away from the 3x plus 1, this 2 is currently a positive 2. And so since it's a positive 2, we need to subtract 2. If we subtract 2 on the left, subtract 2 on the right. So 2 minus 2 cancels to be 0, and I'm left with the negative of 3 to the x plus 1 equals, what's negative 2 minus 2? Negative 4. Okay, so we're getting there in that now we have more just the power by itself. Now I have one slight problem left before we take the log. They're both negatives. And my problem is we can't take the log of a negative number. Any thoughts on how to get rid of these negatives?
Yeah, we have to make it positive. You have to add the 4.
Okay, well, we've already separated them. How about you suggested, okay, we could multiply both sides by negative 1. The other idea, if you're not a fan of multiplying both sides by negative 1, we could divide both sides by negative 1. They're equivalent thoughts. Okay? Regardless, what happens when you multiply or divide both sides by negative 1? All these signs change. So the negative of 3 to the x plus 1 becomes positive 3 to the x plus 1. Negative 4 becomes positive 4. Just like when your equation solved. Now, I have 3 to the x plus 1 equals 4. Power on one side, number on the other side. What have we been doing? We want to take the log of both sides. So we're going to write it as the log of 3 to the x plus 1 equals the log of 4. Now what? Okay, now we're ready for power property. Now we're back into the world you guys know. This is what we were doing on Wednesday. Power property says because this is a log, only works because it's a log, we can pull that x plus 1 out front. So I have x plus 1 times log of 3 equals log of 4. Now what?
divide.
Okay. What are we dividing by? My job is to get x plus 1 by itself. So divide by log 3. If I divide the left by log 3,
Let's divide the left by right.
divide the right by log 3. So when I do this, I personally like to write x plus 1 equals, and then I just leave it in fraction form right now. You want to go ahead and get that decimal. That's fine as well. Regardless, what's my final step? If it's x plus 1, subtract 1. If we subtract 1 on the left, subtract 1 on the right. So I now know my answer is log 4 divided by log 3 minus 1. As I mentioned previously, have you practiced with your calculator that you like to use?
Yeah.
Okay, there's multiple different ways to use these calculators. So personally on this calculator, I like to log 4 divided by log 3, and I like to equal that, and then subtract 1. Does your answer match my answer?
Yeah.
Good news. We've been going 4 decimal places, so what would 4 decimal places be? Okay. It's currently 0.2618. The 5 tells the 8 to go up. So we are going to go 0.2619.
I figured it out on my calculator.
Good.
I know where to press the equals.
Okay, on the back side, when you're ready, we're not going to do all these problems. I think I'm going to do one of the word problems and then, I don't know, maybe 4 out of the 6 problems at the bottom. I'm trying to get you guys a little bit of work time at the end. And then also if we need to, I don't know if anyone in this class has Khan Academy issues we need to figure out on your accounts or anything. I don't know. I know there's been some issues, so if there's anything we need to figure out there, we can do that. The shorter problem is no different than the first. The second problem is no different than the first problem. It's just they aren't giving us all the initial information. So it's all the same. Okay. The equation T of x equals 1,200,000 times 9,300 raised to the x is used to model a lumber company that has 1,200,000 trees and plans to harvest 7% of the trees each year, where x is in years. How many years will it take to harvest half of the trees? So good news. They give me a formula, yes? So T of x equals 1,200,000 times 0.93 to the x. Now, if you notice when you read the problem, it talks about that equation is modeling the 1,200,000 trees. That's already in the equation, yes? And it also talks about plans to harvest 7% of the trees each year. That 7% is already in there. I don't know if you see it or not. But if you're harvesting, you're taking away 7% of the trees. So 100% minus 7% leaves you with 93% of the trees. So that first sentence, they've already gotten all of it. Question. How many years will it take to harvest half of the trees? Thoughts on where to go with this or what to fill in?
X. No.
We're trying to find x.
Yeah.
Because x is in years and we're asking how many years. Which means I need to fill, if we're trying to find x, I need to fill in something for t.
Half of the tree. Trying to get keywords. Years. Let's just put 7%. 7%. Well, that's a 90.
How about we focus on half of the trees? I heard it somewhere. Half of the trees is how many? 600,000? Okay, so right there, half of the trees means the T I'm trying to solve for or find is when T of X is 600,000. So when there's 600,000 trees. So that means I'm going to make my equation equal 600,000. So 600,000 equals 1,200,000 times 0.93 to the X. Kind of think of this as the previous problem we did. Where the previous problem, I couldn't get the bases the same, so I had to take the log of both sides. But before I could do that, I had to get it so I had the power all by itself. So it was a number raised to a power. With that in mind, what are we going to have to do here? What do I have to move? Okay, so this 1,200,000 number, we have to get it away from 0.93x. If it's 1,200,000 times 0.93x, how do I move it? We divide by it. So I'm going to divide by 1,200,000. If I divide the left that way, we're going to divide the right by 1,200,000. What is 600,000 divided by 1,200,000? Think about it. You already know it in a way. What? 0.5? Because 600,000 was half of 1,200,000. So this is 1/2 or 0.5 equaling to 0.93 raised to the X. Well, that problem looks a lot less messy now with a lot less zeros. This problem looks a lot like the front side of the paper, if you ask me. Yeah, it does. 0.53 equals 0.93x. Can you get your bases the same? No, they're decimals. Don't even try. So what's plan B if we can't get the bases the same? Take the log of both sides. So the log of 0.5 equals the log of 0.93 to the X. Same old process, guys. You should be getting good at it by now. Once you take the log of both sides, power property moves that X out front. So the log of 0.5 is equal to X times the log of 0.93. How do I get X by itself? Divide by that log 0.93. Okay. Do the calculator math. Whatever log of 0.5 divided by log of 0.93 is. I do not have, on this particular one, I did not go 4 decimal places. I just have 9.55, which is around 9.5 years, right? If you're going to whole years, you could say it was 10 years. Okay. The other part of the word problem I was not going to do. They just changed 5% to 7%. So that means instead of taking 7% from 100% and getting 0.93, you'd be taking 5% away, and so you'd have 0.95 in your equation. If you want to work it and try it, I can tell you the answer I have written down is 13.51 years. Other than that, I plan to move to the bottom section. We have solved lots of exponential equations. We have used logs, but we have not solved any equations that start with logs. So the format we are looking for is what we already have here, where we have a log of something equal to a number. I need a way to solve this.
Can you put log in the in front of 4x and -3?
No.
Can you divide the whole thing by x?
No. No. We had a phrase we learned. There we go.
Left, right, middle.
Left, right, middle has come back. If you recall, left, right, middle, or what Shelby affectionately referred to as LERM, however you want to refer to it, is what can take us out of log form into exponent form. And in fact, you may have used this some on your Khan Academy yesterday. Maybe, maybe not. Could have used other ways to do them too. But left, right, middle. Now, in order to talk about left, right, middle, what am I missing? What's not showing on this problem? A base, right? So I don't know my left number. What is my base if it's not showing? 10. So this is log base 10 of 4x minus 3 equals 2. Do you remember how that left, right, middle works? Left is 10 raised to the right, which is 2, which equals the middle, which is 4x minus 3. So 10 to the second equals 4x minus 3. Left, right, middle. 10 to the second equals 4x minus 3. What's 10 squared? 100. So I have the equation 4x minus 3 equals 100. You've been solving this type of equation since 6th or 7th grade at this point, easily. How do I solve if it's 4x minus 3? You add 3. We add 3 on the left. We add 3 on the right. 4x is equal to 103, and now we're going to divide by 4. I'm not against the fraction answer of 103 over 4, but I do have a decimal answer on my paper. What's the decimal? 25.75. We've done something like that previously. Whether you remember or not, I don't know, but we have done something like that previously. Well, where we had to use the left, right, middle to get out of log. We did it more, though, when we were just trying to say, find what is log base 5 of 125. Where we had to then make it equal to x and go from there. Okay, let's try B. I'm probably going to skip C if you want, to be honest, but let's try B. Log of 3 minus 2x equals negative 1. So I've got a log equal to a number. What's step 1? Left, right, middle. What is my left? Okay. Log is base 10 when it's invisible. So left, right, middle says 10 to negative first equals 3 minus 2x. What do you know about that 10 to the negative 1? Okay. You can either think in fraction form, and then it moves to the denominator, and it's 1 over 10, 1/10. Or, what's your calculator tell you if you put it in the calculator? 1/10, but in decimal form, 1 over 10. With where we have to go, you guys would probably be more comfortable going decimals. So I will write it as 0.1 equals 3 minus 2x. How do I get x by itself? Okay, if I'm trying to move that positive 3 away from the 2x, I'm going to subtract 3. I subtract 3 on one side, subtract it on the other side. 0.1 minus 3. Negative 2.9 equals negative 2x. To solve for x, I'm going to divide by negative 2. Negative 2.9 divided by negative 2 is positive 1.45. Okay, are we feeling confident enough on those? I'll tell you the answer for part C is 19.6 is what I have written down. And again, if you've been able to follow what we've done on A and B, then C should be a piece of cake. Okay, I skipped C because I want to get down to row 2. What's different about this bottom row? It has 2 logs. I can't use left, right, middle when there's 2 logs. It's not an option. Left, right, middle works when we have 1 log equal to something else, equal to a number. Thoughts on what I can do since I have 2 logs? I couldn't hear what you guys said. Combine them. How do we combine them? I agree. Do you remember those properties we learned? Two logs being added can be rewritten as 1 log where the insides are multiplied. Yeah, 2 logs being added can be rewritten with 1 log where the insides are multiplied. So log of x minus 3 plus log of x can be rewritten as the log of x minus 3 times x. Now, I have to put those all in parentheses because I have to show that x minus 3 and x are attached to that log. I would go ahead and multiply them together if you haven't. How do we multiply x times x minus 3? Take that x and distribute. So I can write this as the log of, what is x times x squared minus 3 times x, 3x. Okay. So now I'm at the point of log of x squared minus 3x equals 1. What? What are we doing here to get out of this? Left, right, middle, which we have a base of 10. So left, right, middle is going to have me rewriting this as 10 to the first equals x squared minus 3x. Thoughts on where to go next? How do we solve an equation when there's x squared and x terms and a number term? What? Factor. Before we can factor, what do I have to do? Make the equation equal to 0. Okay, so make this equation equal to 0. So if I make it equal to 0, I'm going to keep the x squared minus 3x where it is. 10 to the first is just what? 10. So I'm going to subtract the 10 over. So now I'm going to have x squared minus 3x minus 10 equals 0. And I guess it was suggested factor. We hope it's going to factor, right? Because the backup plan, if it doesn't factor, is we have to go quadratic formula. So, okay, do you guys remember how to try factoring though? Good news is we don't have to worry about that. Let's factor. Remember 2 parentheses. What do you know about x squared? X and x in the front of those parentheses. I know it's been a while. Sophomores, you've got ISTEP coming up next week, though. So could you see factoring? Could you see solving equations like this? Okay, you're not going to see the logs, gentlemen. You're not going to see the logs. But the x squared minus 3x minus 10 equals 0, studying equal to 0, being able to factor and solve that, that's very much ISTEP material there. Okay, what has to happen here? We need a product of negative 10 and a sum of negative 3. What multiplies to be negative 10 and adds to be negative 3? Okay. It's a combination of 5 and 2, because 5 minus 2 is 3 since it multiplies to be negative. I want that negative 5. So negative 5 plus 2. Am I done? Okay, don't stop there. Set them both equal to 0. X minus 5 equals 0. X plus 2 equals 0. Okay. So we add 5, we get 5. We subtract 2, we get negative 2. So answers of 5 and negative 2.
We have to check for strain solutions.
Smiling.
Maybe. Okay. So, notice we did get 2 solutions. And I'm not saying there couldn't be 2 solutions necessarily. But here's the problem I see. I'm talking about logs. And I came up with a negative solution.
Oh, well, that doesn't work.
Okay. So, depending on the situation, there's a good chance it doesn't work. Because remember, you can't take the log of a negative number.
So all of that just doesn't work.
Well, when I put the negative 2 in, notice what am I going to have to do right here? I'm going to have to do log of negative 2. If you haven't tried it on your calculator, notice what happens when I do log of negative 2. I get a domain error. A domain error meaning that this, you can't have that kind of input. You can't have a negative log. Now, what about the 5?
That might work. I mean, it has to
5
be.
minus 3,
Reading your whole question.
5. It works, okay? So it's not that you have to specifically do like a real in-depth check, but if you get a negative solution or if you get something that will make a log negative, you have a problem. So just beware. Okay? Let's do one more. Let's do E, then I can get you guys a little bit of work time. Log of 6 minus log of 3x equals negative 2. Quotient property. If 2 logs are being subtracted, rewrite it as 1 log where the insides are what? Divided. So the log of 6 over 3x equals negative 2. Now I've got 1 log equal to a number, so what am I going to do? Left, right, middle. Divisible base of 10, so 10 to the negative 2 equals 6 over 3x. What do you know about 10 to the negative 2? Okay, calculator says 0.01. It's 1/100th. It's 1 over 100. You can go a fraction or a decimal. It doesn't matter. I'll give in and go the decimal route. You can go the fraction route if you want. Now, okay, I've got a fraction. How do I get rid of a denominator in a fraction? Multiply. If it's 6 divided by 3x, we want to multiply by that denominator of 3x. If I multiply one side by 3x, multiply the other side. What is 3x times 0.01? About 0.03x. 3 times 0.01, 3 times 100th, it's going to be 300ths. On the other side, the 3x's will cancel, and I have 6. Okay, home stretch, easy part. If it's 300ths x equals 6, we need to divide by that 0.03, or that 300ths. X is 200. Okay. 200 seem like it'll work?
Yeah.
Yeah, it's not going to make a log negative or anything, and that's the key. I'm not going to do F. If you want to check it, look at it a little bit in Math Excel. If there's anything we need to check in Khan Academy. I will tell you on F, your answers are 5 and negative 5. And they do both actually work because when you put that negative in, you have to square it. So that's what allows it to work. You haven't already looked at it. It's less than 7.5 in Math Excel. So you had the right, you were just off by 100 there somewhere. So probably just really a careless mistake then.